So this is the inlet manifold from a Vauxhall Vectra 1.9 16 valve, the 150 brake horsepower version. As we all know, these suffer with flaps, the swirl flaps sticking, and then the little arm pops off and causes all sorts of issues. You can actually get these manifolds from Alphas without the swirl flaps actually in. The only thing that the swirl flap does is it creates additional swirl at low engine speeds, but if anybody wants to take the time to actually have a look at one in operation, literally as soon as you touch the throttle pedal, even from idle, they spring open. So it is literally just something that works at idle, really. On this particular manifold, I've used, if you can see them, the actual blanks. Now the blanks have been held in with chemical metal. This is the third manifold that I've made like this. The last manifold that I made is still in use and has been for 2 years, running 2.6 bar boost, so there is no issue with these jumping back out or popping out or anything like that. Inside the actual runners, you can see that the little holes in the bottom where the swirl flaps would normally be has also been filled in and smoothed out. You can see that here and here. And obviously the main part of this is that I've actually removed the Anti Shudder valve. The Anti Shudder valve is often called a throttle body. It isn't a throttle body. Basically, it's only there, its only purpose is to help mix the EGR part and to shut the engine down smoothly to prevent a nasty little rattle when the engine shuts down, which helps to protect the dual mass flywheel. And the other thing that it does is, if you ever have a turbo which runs away on its own oil, then obviously when you switch the ignition off, that flap will shut and strangle the engine. The problem that you get on cars which are running bigger turbos, like this one will be shortly, is that this is a real restriction. So there is the Anti-Shudder valve. As you can see, it's all black and gunky and horrible. The actual throat of the Anti-Shudder valve is reduced. So if I turn it over, you can actually see that the pipe itself, the original size, is quite considerably reduced by about a centimetre all the way around, which is quite a size really. And the reason that that's done is because it just makes it easier for that valve to close and restrict the airflow. The problem is with bigger turbos, and even possibly on the standard turbo, is that it creates a degree of back pressure, which is obviously the turbo is going to struggle to overcome, which means that you've got VNT being used to create more boost to push past it, which then again creates back pressure in the exhaust and all sorts of other problems. If you look inside the actual runners in there, like you can see, it's all nice and smooth. Everything's been sealed up correctly as it should be. The manifold can actually be split apart. So if you spin it over, you can see that the manifold can actually be split into two pieces. It was split into two pieces mainly to clean it and to just do a little bit of fettling and clean up the runners a bit. That was done, and then it was sealed back together using Tiger Seal, again a method which I found is very good, because it means that the Tiger Seal will be a very good seal for running high boost pressure. The swirl flap motor is left on, but it is actually disconnected. You can see the arm that would normally operate it, which is here, is disconnected. The reason for that is simply then you don't have to worry about mapping things out. You can just plug the motor back in and it will operate as it should do. On the back of here, you can see the manifold would normally have the EGR valve sat there. That's actually been literally cut straight off there, so you've got no issues with EGR being puked into the inlet manifold and creating the problem that we've just deflapped to get around. But part of the EGR valve does actually serve a purpose, as in it holds the engine cover on. So we've actually cleaned that bit there up, refitted it just so that the engine cover is not flapping around, so that it's properly put on. Obviously that's where the map sensor would normally sit. That'll be cleaned up a little bit in a minute. As you can see, it's all nicely painted with heat proof paint. So it's going to look really nice when it's on there, and it does serve a purpose. At the end of the day, you know, will removing the swirl flaps give you additional power? Well, it very much depends on the specs of your engine. It very much depends on what turbo you're running. This one will be very shortly running a hybridized 56. It's been taken out to a 60, so it's a GTB 2260, or it will be shortly, and we'll be running higher boost. So we're not going to have a problem with any restrictions in this manifold holding us back. Would this be a benefit on a standard turbo? Yes, it would. Most of these engines, when you take the manifold off, they're so gunked up that literally by even just cleaning them and taking the flaps out will give you an additional sort of 4 or 5 horsepower, and certainly helps the engine to breathe a lot more freely and accelerate better. So yeah, it's definitely a worthwhile modification.